Hey there and welcome. Today, we're diving into something we all breathe in every single day, but never actually see, air pollution. But, we're not just talking about the smog you can see hanging over a city. We're going after a threat that's completely, totally invisible, and maybe a lot more dangerous.
Yeah, we've all seen those pictures of hazy skylines, right? It's easy to think that's the problem. But what if the real danger isn't the haze itself, but the microscopic stuff hiding inside it? That's the big question we're tackling today. So first things first, let's really get a handle on what this problem is. We're talking about a health threat that operates on a scale that's, well, it's almost impossible to wrap your head around.
These are called ultrafine particles, or UFPs for short. And look, these aren't just little bits of dust. They are incredibly tiny pollutants, so small they're actually smaller than a virus. Because of that size, they can sneak right past our body's natural defenses, get deep into our lungs, and even push into our bloodstream, causing real trouble for our heart and other organs.
And just how small are we talking? About 10 nanometers. Now, to give you some perspective, a single human hair is around 80,000 nanometers wide. So yeah, we're talking about a truly microscopic scale. And that's exactly what makes these things so tricky, so hard to track, and unfortunately, so easy for us to breathe in.
And this, right here, gets us to the core of the challenge. For environmental agencies, for researchers, if these particles are basically invisible, how in the world do you count them? And if you can't count them, how can you regulate them? How can you possibly know what their real impact is?
So, how do you fight an invisible enemy? Well, this is where some really clever technology comes into play, offering a pretty brilliant solution to a microscopic problem.
Meet the AVL Ultrafine Particle Monitor, or UFPM. This is an instrument designed for this exact challenge. It's built on decades of experience in measuring particles, giving us the accuracy we finally need to start counting the invisible.
So the big question is, how does it actually work? How do you count something that small? Well, the method is incredibly clever, and it all starts with one simple idea. Just make the particles bigger.
The principle behind it is actually something you already know. Think about seeing your breath on a cold day. The warm water vapor from your lungs hits the cold air and instantly condenses onto tiny particles, forming little droplets that are suddenly big enough for you to see. The UFPM uses that exact same trick.
Now, the official name for this is condensation particle counting, or CPC. The machine pulls in an air sample and uses a special vapor to grow a little liquid coat around every single ultra-fine particle. This makes them thousands of times larger, turning them from invisible specks into droplets that we can actually detect.
The whole process happens in 3 really straightforward steps. First, the air sample gets saturated with that vapor. Then, as it cools down in a part called the condenser, the vapor grabs onto the UFPs, causing them to grow into droplets. And finally, these new, bigger droplets fly through a laser beam. Every time a droplet passes, it scatters the light, and a detector counts the flash. One flash, one particle. It's that simple and direct.
Okay, so a brilliant method is one thing, but it's only useful if the machine actually holds up out in the field, right? Well, this device was born from one of the toughest testing grounds you can imagine.
See, the tech inside the AVL UFPM was first perfected for the auto industry, measuring exhaust emissions under really extreme conditions. And what that means is that its core guts are engineered for incredible durability and super consistent performance, whether it's sitting in a pristine lab or on the side of a busy highway. And that toughness translates into some serious reliability. Its optical parts are built like a tank, it's smart enough to detect if its own measurements are drifting, and it can even reboot itself after a power outage so you don't lose precious data. Plus, it's compliant with key European standards, which means the data it produces is trusted by official agencies and research networks.
And it's also designed for the actual people who have to use it every day. Maintenance is kept really simple. There's a key part called the wick you can swap out in a minute, no tools needed. It's also really efficient, sipping its condensation fluid, and it's made to plug right into existing air quality stations without a fuss.
And this stuff really pays off. For instance, the government office in Styria, Austria, pointed out just how reliable and easy to maintain it was, and how it fit right into their existing network. That's some serious real-world proof.
All right, so we've got the problem, and we've got the tool. So let's look at the final piece of this puzzle. How does all this data actually lead to cleaner air?
Well, this instrument is incredibly versatile. In a city, it can clearly show you those pollution spikes during the morning and evening rush hours. But at the same time, it can be sitting at a high-altitude research station in the Alps,
providing perfectly accurate data in extreme conditions. It really works anywhere.
And the quality of that data, it's just rock solid. Check this out. Testing from the World Calibration Center for Aerosol Physics shows how incredibly stable these devices are. Their calibration factor, which is basically a score for accuracy, is consistently hovering right around a perfect 1.0. That is exactly the kind of precision that scientists dream of. And this, right here, this is the whole point. Once you have precise, reliable data that you can trust, you can finally take real action. You can pinpoint where pollution is coming from, understand its impact, and design smart strategies to actually reduce it. Bottom line, measurement is the first step to management. It's this level of quality that gets the attention of the experts. Leading research groups like Germany's Tropos Institute have actually added the AVL UFPM to their collection of world-class instruments because its high standards have earned it a spot among the very best.
At the end of the day, it's a pretty powerful story. We started with an invisible threat that we couldn't even get a handle on. But now, with the right tech, we can literally make those particles visible, turning abstract numbers on a screen into concrete action for a healthier world. And that leaves us with one final thought. For the very first time, we have the ability to see the complete picture of particle pollution. So the question isn't really if we can measure it anymore, it's what are we going to do with that knowledge?